Well, hey guys, how you doing today? Welcome back to my YouTube channel. Thanks for joining me today. Well, the day is finally here. It's a day I've been waiting for quite a long time. We've got the first solid evidence of parallel realities. This is a topic that you've heard me talk about for a number of years here. I've been investigating it ever since I learned about Hugh Everett at Princeton, 1957, with his so-called many worlds model that he proposed in his dissertation, which people at the time thought was so crazy. His thesis advisors made him whittle down all these ideas to just 37 pages and stripped of all really some of the best ideas. Also, more recently, I've talked about the many interacting worlds model, which is another model of parallel realities, which suggest we're surrounded by billions and billions of parallel realities whose kind of interference with our own reality generates what we call quantum mechanics. We've also heard from Max Tegmark over the years, whose book, The Mathematical Universe, argues that there's at least 4 different ways that multiverses could exist, some of which involve just the fact that the universe is expanding and it's infinite and it just goes on forever and ever. So eventually, you're going to start seeing copies of yourself and things here are going to show up in other places that are identical. Bubble universes and so forth. But this is a new idea and I'm really excited about it because we have experimental data. We've got evidence about how this parallel reality could in fact exist. It comes out of this very recent article from New Scientist magazine about a mirror universe. And it doesn't just flow from some sort of fanciful thinking or metaphysical ideas or anything like that. It's based on the fact of something in physics called parity violation. In physics, there's this idea that the forces of the universe are symmetrical and that things work the same in time, forward and backward, that particles can exist as symmetrical versions of themselves. This goes all the way back to the ideas of Paul Dirac from 1920s, who proposed the idea of antimatter, right? For every particle that we see here, there's antimatter particles. And then about 10 years later, Fritz Zwicky proposed the idea of dark matter because he saw the way that galaxies were rotating. There had to be some extra matter there that we couldn't see that was accounting for how the galaxies were holding together, even though they were spinning. Vera Rubin in the 1970s saw the same sort of dark matter effect across clusters of galaxies in our universe. But the issue of parity violation was raised by Leah and Yang in their Nobel Prize-winning work about neutrons, because what they found is that the neutron does not obey symmetry. It doesn't have mirror images of itself. If you look at most particles, they can exist left-handed and right-handed versions, but the neutron is only kind of a left-handed version of it. There's no other version of it in our universe. So what's going on? Also, experiments with neutron decay, neutrons that are outside of the nucleus of the atom, where the strong atomic force holds them together in a very permanent way, a very strong force that allows matter to exist the way we know it. Outside of the nucleus, they decay in around 14, 15 seconds, and there's always been this 9-second discrepancy, depending on how you measure them, of how long it takes them to decay. And it was found that if you measure it using a magnetic beam to kind of herd the neutrons into a confined space, that they last 9 seconds less. And nobody knew why. They thought for a long time that it was an experimental error or something, but it's never been resolved. And the latest thinking is that when you expose neutrons to these magnetic fields, it makes them oscillate a little more, and they're disappearing into another universe. Neutrons, when they decay, break up into protons and electrons. In this case, there are too few protons in our universe from this decay. The research coming out of Oak Ridge National Laboratories, Leah, Broussard, and Zurab Barazani from the University of L'Aquila in Italy argue that about 1 out of 100 neutrons in our universe is being shared with a parallel universe. And this goes so far as to explain what dark matter is. Remember, Vera Rubin and Fritz Zwicky, who are the discoverers of dark matter, we've never identified what it is, even though it's about 30-40% of the universe, no one knows what it's made of. There's 5 times as much dark matter as regular matter, and the missing neutrons would explain where the dark matter is coming from. Because in the mirror universe where they're going, the proportions are exactly inverse. There's 5 times as much matter as dark matter. And this sort of thinking suggests that the missing neutrons are actually being shared between our universe and another parallel reality. Now, there are more experiments to be done to actually ascertain that this is what's going on. It involves shooting neutrons into mirrors and measuring the changes with varying magnetic fields. But this is very exciting because a lot of people have argued that there's no evidence for parallel realities, that it's metaphysics, that there's no way to test for it. You've probably heard this. There's no way to test for the idea of multiverses or anything like this. But now we have a test. And so I'm excited to see what emerges from these tests. I'll read you just a little bit from the article. The uncanny world on the other side of the mirror may not seem real to you, but Leah Broussard thinks parallel universes where everything is flipped might be very real indeed. Along with her colleagues at Oak Ridge National Laboratory in Tennessee, she's on the hunt for a universe that is identical to our own, but flipped so it contains mirror atoms, mirror molecules, mirror stars, planets, and even mirror life. If it exists, it would form a bubble of reality nestling within the fabric of space and time alongside our own familiar universe, with some particles capable of switching between the two. Okay, so how about that, guys? Particles in our universe, you see them around, are going off into another parallel reality, spending some time there and then coming back. How about that? And what else is coming over from that parallel reality? What else is coming through the wormhole? This parallel reality is not way out there like the example I mentioned from Max Tegmark, the Type 1 multiverse, where it's just so big that it begins repeating itself in either Type 2 bubble universes because of the expansion of the universe. It keeps going, so-called eternal inflation, creates universes that haven't even kind of contacted other universes. This is a universe that's intertwined with our own. It's right here, enmeshed in the fabric of our own reality. It's right next to us. It just is based on mirror particles. So there would be, like in those Star Trek episodes, a dark Kirk and a dark Spock. It's actually, they predict from here, more experimental ideas that it would be colder than ours, this mirror universe. And they go on to speculate that it would contain life forms that are different from ours, but sort of mirror images. So related to us, but different. Now, this is really weird. I mean, maybe you thought the first things that were going to come to us were ETs or something like this. Is it possible that these Tic Tacs that have been seen off the West Coast and the flying cubes off the East Coast are in fact scout craft coming from this parallel universe to map out our world to see what's going on here? I mean, we don't really know. But again, these are really exciting developments. And so one other interesting implication of this is that there would be more material in this other universe than in our universe. I mean, you would think our world is already kind of materialistic, but this other one is even more. Listen to this. Since the particles left behind went on to form stars, planets, and eventually people, it seems reasonable to expect that there is also a mirror version of life, and significantly more of it than we can see. In the mirror universe, it would happen 5 times more frequently, says Bereziani. Who knows, there might even be a race of mirror humans trying to work out why their dark matter is 5 times less abundant than their normal matter. So, this is a really exciting development. I've been hearing people say for quite a while, there's no evidence for it, it's just an idea. But it's no longer just an idea, it's something that we can test. It's something that explains dark matter, and it explains some of these discrepancies in neutron decay rates. I think it's very exciting. And who knows, we may already be seeing evidence of this parallel universe in our lives right now. I'm not sure if it suggests, since there are 5 more particles material particles in that universe than in ours. Does that mean there's 5 of you and me there for every one of us here? I don't know, but it's something to start thinking about. You could use your imagination and kind of imagine what it'd be like to contact this parallel reality. Anyway, that's it for now. Thanks again for watching. We'll see you in the next video. Take care, and bye-bye.